How can we represent alphanumeric information using binary digits? Well, we can do whatever we want because at the end we are working with electrical signals and ones and zeros, but we can write whatever we want and interpret it as we want. We have seen when working with numeric information, we can use different representations, complement one, complement two, more complex representations for real numbers. So we can do whatever we want. So the first engineers working with computer choose to use a table for represent alphanumeric information. So for example, if we have a string, potato, they decide to use one byte for each character. For example, here we have 1, 2, 3, 4, 5, 7. They used one byte for each char to be represented. And a byte has 8 bits. We have 1, 2, 3, 4, 5, 6, 7, 8. They use the first 7 bits to represent the character and the last one for correcting errors because the networks were very unreliable at that time and they used that bit as a control for transmission errors. Maybe we will see something about it later when we in the unit or in the networks unit. So with 7 bits, you have 128 different possibilities. So they made a table, and each number corresponds a different character. For example, and I can remember the 34 will be the character 4, the 65, the A, and so on. This is the ASCII table. It was called the ASCII table. We have an example here. And this is, you can see the table. This is the different representations, decimal, hexadecimal, octal, and this is the character represented by that number. You have here a bunch of non-letter, some characters that are not letters, some of them used for communications. And here, as you can see, you have how to represent numbers, how to represent uppercase letters, how to represent lowercase letters. Okay, so for example, if we want to represent an A, we need to write a 65 or 41 in hexadecimal. So if we open the file, okay, let's open the file again, write an A, save the file and open it with the hexadecimal editor, and we have here the 41. So it's a 41 because in the ASCII table, this is the number used for representing a uppercase A. If, for example, we put a 4, as we have seen before, if I reload the file, we have a 34. 34 corresponds to the number we use for representing the character 4. And this character, the 0A, is also a character that we have in the ASCII table. Here, 0A is this one is a new line. So the editor is adding a new line at the end of the file, and it's represented as a character, and it has a number, it's 0A. So if we have more than one number, or whatever, potato, what we do is have a different, a byte for each character. So 50 is the character for uppercase P, 6F for lowercase o, and so on and so on. So here we can see in the X editor we can see the numbers, and the ASCII representation of the numbers.